Welcome to Math and Meditation. In this video we are going to look at a couple of problems in algebra. But before we start, we're going to do our usual relaxation. And we're going to take deep breaths, and during each one of the out breath we're going to relax a part of our body. We're going to start at the bottom and then work our way up. So we take in the deep breath, and when we let it go, we relax the feet. During the second out breath, we are going to relax the legs. We are going to breathe all the way down into our stomach. During our third out breath, we are going to relax the hips. We breathe down into the stomach. And we let the tension go. During the next deep out breath, we're going to relax the stomach area and the chest. Then we'll relax our arms. And then chest and shoulders. And finally our head. Now, with a more relaxed mind and body, we start to focus on the mathematics. So, the first problem we're going to look at is the following question. So we have a magic number. If we square that magic number and the outcome is 4, what was the original magic number? In mathematical terms, we write this as the magic number a squared is equal to 4. So now the question becomes, what is the reverse operation of squaring a number? And it turns out that the reverse operation is taking a square root. So as before, we need to apply the same operations on both sides. So now the left hand side is equal to the right hand side. To maintain the equality, we need to apply the same operation on the left and on the right. So now we apply the square root on both sides. A squared equal to 4 square root of 4. Now the square root is actually the opposite of the square, but there is a caveat here. So the thing is that when we square something, it doesn't really care whether it is a positive number or a negative number. So to take that into account, we need to add a plus minus. It's actually better or more clear to keep it on the other side. So we have a plus minus here. Now the square root of 4 is 2. So we have a equal to plus minus 2. So the plus minus business here is probably best understood by looking at actually placing a, or positive or negative 2 into the original equation. So if we do 2 squared, we get 4. But if we do negative 2 squared, we also get 4. So both 2 and negative 2 are the answer to our problem, and this is the way we express that. A equal to plus minus 2. Now let's switch over to the next problem, which is the following. So negative 5 times 1 minus 5a plus 5 times negative 8a minus 2 equal to negative 12. So now the first thing here is to multiply the negative 5 into the parentheses here. So we need to do 2 multiplication by the distributive law. We need to multiply 5 by 1, and we need to multiply 5 by 5a. So negative 5 times 1 is negative 5. Now, negative 5 times negative 5 is positive 25. So we get positive 25a. And now we need to do the multiplication with 5 as well. So we need to multiply 5 by 8a, and we need to multiply 5 by negative 2. So 5 times negative 8 is negative 40, so we get negative 40a. And 5 times negative 2 is negative 10, we get negative 10, equal to negative 12a. Now let's collect together similar terms. So negative 5 minus 10 is negative 15. 25a minus 40a is negative 15a, equal to negative 12a. Now we do want to get the a's on one side and the numbers on the other side. So let's add 15a on both sides. So we have, and same here as before, we always need to do the same operation on both sides so that we keep the equal sign. So we have 15 minus 15a plus 15a equal to negative 12a plus 15a. So we have added, let's wipe this out, not 8 but a. There we go. So now we have added 15 on both sides. So what we're left with is, so this cancels out this. So we have negative 15 on the left hand side, and we have 3a on the right hand side. Now we want to get rid of the 3 on the a side because we want to have only a on one side. So this is 3 times a, so this is multiplication. To cancel out multiplication, we need to use division. So we divide by 3 on both sides, leaving us with -5 equal to a. We have figured out what a needs to be for the original equation to hold. Now, a good way to test whether we got the answer right is to plug it back into the original equation and see if we get it to be correct. So thank you for following us on Math and Methodation, and I hope you will join us again.